Hello everyone, welcome back to our channel. In today's video, we are going to learn about one of the most important components in electronics, the inductor. We will discuss what an inductor is, how its work, its construction, different type of inductor and where it is used. So let's get started. First, what is an inductor? An inductor is a passive electronic component that stores energy in the form of magnetic field when electric current flows through it. The main function of an inductor is storage energy in a magnetic field and resist sudden changes in current. This property is known as inductance. The unit of inductance is Henry, represented by the letter H. Smaller values are often expressed in millihenry or microhenry. This is the circuit symbol of inductor. Whenever you see this symbol in a schematic diagram, it represented an inductor. Now, let's look at how an inductor is constructed. The construction is quite simple. A conductive wire, usually copper wire, is wound into a coil. Different core materials are used inside the coil, such as air, iron, or ferrite, depending on the application. Let's take a quick look at each of these types. First, air core inductor. As the name suggested, this type of inductor does not use any magnetic core material. Minimal core losses at high frequencies. It's ideal for RF and high frequency application. Low inductance value but excellent performance in gigahertz range. Next, the iron core inductor. In this type, the coil is wound around an iron core materials. Significantly increases inductance value, suitable for low to mid frequency applications, common in power supply and audio equipments. Finally, let's look at the ferrite-core and SMD inductors. This type uses a ferrite core, which is special magnetic material. Finally, let's look at the ferrite core and SMD inductor. This type of inductors uses as ferrite core, which is special magnetic materials. In ferrite core, low eddy current losses and it's ideal for high frequency circuits. SMD inductor, which is surface mount, it's used for compact design for modern PCB and portable electronics. Now let's understand the working principle of an inductor. When electric current flows through the coil, a magnetic field is created around it. This magnetic field stores energy, just like a battery stores energy in a different form. If the current tries to increase or decrease suddenly, the inductor resists that change. It does this by generating a voltage in the opposite direction, known as back EMF. This behavior is explained by Faraday's law of electromagnetic induction. When the current flow is removed, the magnetic field around the coil begins to collapse. As the field collapses, the stored energy is released back into the circuit. Mathematically, this behavior is represented by formula. This is the formula. Here, V is the induced voltage, L is the inductance, and di by dt represented how quickly the current is changing. A faster change in current produces a larger induced voltage. So let's see, why do we use inductors in electronic circuit? One of the main reasons is that inductor resists sudden changes in current. This helps make the current flow smoother and more stable. Inductors can also store energy in a magnetic field and release it when needed, which is very useful in power supply circuits and DC-DC converters. Another important use in filtering. Inductors can block or reduce unwanted high-frequency noise while allowing the desired signal or power to pass through. Because of this property, inductors play a key role in power electronics, communication system, filter, and many other electronics devices. Before ending the video, here a quick comparison between a capacitor and an inductor. Both components can store energy, but they store it in different form. A capacitor stores energy in an electric field, while an inductor stores energy in a magnetic field. Also, capacitor opposes changes in voltage, whereas the inductor opposes changes in current. And that's it for this video. I hope you now have a better understanding of inductor and their role in electronics. If you enjoyed the video, don't forget to like, share and subscribe. Thanks for watching and see you in the next one.